All right, guys, so we are now at number 8 of this January 2024 CSEC math exam, paper 2 video solution. All right, we're now starting section 2 with number 8. All right, so it starts out with this coordinate geometry. See those lines are coordinate geometry, and I like these questions where they give you the graph, because a lot of the time we don't need to calculate when the graph is shown. We can count off, for example, the gradient, and we can see the y-axis, intercept, and so on. All right, so the question said, the diagram below shows the graph of two functions on the same axis. The lines G and H are perpendicular. So that's the first thing, they are perpendicular. And so they have negative reciprocal gradients. And that is shown by this symbol right here at the P, all right? P is the point of intersection. So this one is the G, this one is the H. All right, so that's what they want us to do. First thing wants us to determine the equation of line G, which is this one. So to find the equation of that line G, we need to know two things about it. We need to know, because the form of the equation is y equals mx plus c, talking about line G. So we need a gradient and we need the y-axis intercept, all right? And we can see that the c is where it crosses the y-axis right there at 3. So we know that the c is 3. And then the gradient now, we'll have to determine it, but we can count it off because we can use these 2 points and count off the gradient. It's going to be a positive gradient because this line is sloping upwards. So let's see. So when I use these 2 points to count out the gradient, so it's a matter of counting the rise and the run. So going from left to right on the line. So what will be the rise from here to here? So you're rising from a 0 because you're on the x-axis, and you're rising up to 3. So this is up to 3. So the rise is 3 units. So that's a positive 3. And then we have to run from -6 over to the y-axis. So to run across here to reach the 3, you will have to run 6 units. So that's a positive 6 units because we're going 6 units to the right. So the gradient of line G is rise over the run, and the rise is 3 and the run is 6. So the gradient of line G becomes a half. 3 over 6 is a half. So the gradient of line G is simply half. I can place that here. In fact, I could have placed this down here. Let's move it now. So let's place this here. And what we'll do is see that this is actually MG, since it's line G we want. So MG, CG. So MG, CG. And we're going to add here that the CG from the graph is equal to 3. We can see that right here, the y-axis intercept. So once we have those two values, we are good to go. The equation becomes, let's put the equation in blue now. Equation of line G becomes y equals half x plus 3. So I've placed the half here for the m, and we have placed 3 here for the c. So we say CG, CG, and CG, not 2CG. All right, gradient and y-axis intercept gives us the equation. Easy, 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 easy. Next part wants the equation of line H now. So to find the equation of line H, we need 2 things about it, right? So the first one was that it is perpendicular, but we also have this point that it passes through. All right, so this point is actually the point on G. Let's do G in purple. This point on, not H, on H is a point 4, 0. So it's a known point, 4, 0 on the line H. And because it is perpendicular to G, we can get a gradient. So let's do that. So we're going to use a different approach for this now. So because we have the point that it passes the x-axis, we have this point which is 4, 0. So we have a point 4, 0 that it passes through. And we're going to go for the gradient. So the gradient, let's just give this point a letter so we can reference it, right? So we're going to call this point, since I call this point F, P, I'm going to call this point Q. Let's just call this point Q for now. So we can reference it, right? Just for reference for the solution. And so I'm going to call this point Q. And so since we know the point, we also need to know a gradient, right? To find the equation of a line, we need a gradient and a point. So we have the point already. This time it's not the y-axis intercept. But the gradient, because they are perpendicular, the gradient of H is -1 over the gradient of G, because they are perpendicular. That's why this is so. Remember, the gradient of G was half, right? Gradient of G is a half. Gradient of G is a half. And so to do this calculation, we will take the half and put it on the here for the mg, or the quick way to do this calculation is to flip the gradient that we have and change the sign. So if we flip a half, it's going to become 2. It becomes 2 over 1, and we change the sign to minus. So the gradient of that line, H, is just -2 right here. And then the equation of line 2 now, using the gradient point form, right? Gradient of line H, not the gradient, the equation of line H, equation of H, which is going to be y minus the y value at Q equals the gradient of H into x minus the x value at the point Q. So that's a quick way to calculate the equation, or to find the equation where we have a gradient and a point that is not the y-axis intercept. So we can plug the values in this. So it's y minus the y value at the point that we know is 0. So it's y minus 0 equals the gradient is -2 right here, -2. Gradient is -2 into x minus the x value at the point is 4. All right, need that bracket over here. So what this x value is 4. So subtracting 4. And then we can proceed and finish this. Let's write the 4 better. And so this side just remains y. Y minus 0 is y. Then it's -2 times x is minus 2x. And then the -2 times -4 gives me a +8. And so that is the equation of the second line. All right, that is it. Next part now says the coordinates of P. We have to calculate the coordinates of P and show all working. Now let's look at the diagram. So this point P is the point of intersection of the two lines. All right, so the two lines intersect at that point, and so the equation, to find that point, we need to just solve the two equations simultaneously. Remember that G line was this, half x plus 3. So this was y equals half x plus 3. And this line H was y equals minus 2x plus 8. And so at this point, two equations are equal. Let's say the two equations are equal at that point where they intersect. So the y values on the two equations are equal. And so this expression is equal to this expression at that point. All right. We're basically just solving the two equations simultaneously to find the point P. So we can set it up like this. Two equations are now valid at point P. So we can say at P. Let's make the pen a little bit smaller. So we can say at P, two equations are valid. The y is equal to half x plus 3, and also y is equal to minus 2x plus 8. All right, so that is it. So those are the two equations we're solving simultaneously. So the y value is the same at both points, at that point, sorry. And so this expression is equal to this expression. All right, two expressions, because y is equal, so we can write, and we can say, therefore, the half x plus 3 becomes equal to minus 2x plus 8. what I'm saying is that this y value and this y value equal, all right? Because the one line is saying y is equal to this, and the other line is saying y is equal to that. At the point P, the y values are equal, and so this is equal to this. That's the premise on which we're going to solve it. So to solve this, first I'm going to do is multiply 2 by 2 to get rid of the fraction. Let's work it through. Multiply 2 by 2 first. To get rid of the half. Multiply this by 2, it becomes an x. Multiply this by 2, it becomes 6 equals, multiply this by 2, I get minus 4x. Multiply this by 2, I'm getting 2, 8, 16. And this x comes over here, add to this one, becomes a 5x. And this 6 goes over there and subtract to give me 10. And so when I divide by 2, I'm getting x equals 5. And at x equals 5 is 1 point, I can take the 5 and substitute it here to get the y value at the point P as well. So y would be minus 2 times 5 plus 8. Plus 8. And the y, I'm not liking this fact. No, this is 2. This is not 5, it is 2. This is actually 2. 10 divided by 5 is 2. I was kind of glancing at the other equation, that's why I know something was wrong. And this is now 2. That becomes a 4. That's 8 minus 4. So y equals 4. And therefore, P is a point. P is a point 2, 4. Now we can kind of double check it in the second equation because we put 2 in the other equation, put the 2 here. We're going to get half of 2 is 1. 1 plus 3 is 4. So that kind of confirmed that that is a point. I was making a mistake here a while ago. But I caught myself by glancing at the first equation as I work. But this right here is the answer, right here. P is a point 2, 4. Let's see if it looks like 2, 4 on the diagram. Yeah, above the 3, right? And about halfway to 4, all right. So we can accept that. All right, that finishes that part. Let's go to the next part, which is over here. So which part B now? It's looking like a quadratic. Yes, it is. They're asking us to write this expression in this form. So I'm going to use the method that I teach in class, all right, which is not to use a plus h. I use a method where we write the expression instead as x minus xt, where t is the valid x valid at the turning point squared plus yt. So the t simply means turning point. And when we calculate the xt value, you're finding the x value at that turning point, and yt is the y value at the turning point. So instead of putting a plus, we have a minus there. I'm going to use a formula to calculate xt. The formula is uses the coefficient of the standard form of that quadratic expression. So the coefficient of x squared is given letter a, which is a 4 now. So the a equals 4. And the b is given the coefficient of the x. B is the coefficient of x, which is this time is negative 24. B is negative 24. And the c is a constant term in the expression. And so the c equals, the shift is over. The c is going to be equal to 31. So the c is 31. And the formula for the xt that's coming here, if we're going to use this method, is minus b over 2a. So note, if you learned it with the plus h, then you would not have the minus. It would just be b over 2a. But this method is slightly different, all right? Basically, you're getting the same result in the end. So it is minus b, and the b is this negative 24. So I'm putting minus and negative 24. So this becomes a positive 24. I don't need to put the brackets. But this minus becomes a plus divided by 2 times a, and the a is 4. That's 2 times 4. So this then becomes a positive 24 over positive 8. 24 divided by 8 is 3. And so my xt value is 3. And when my xt value is a whole number, I can calculate my yt value by substituting this xt value back into this function or this expression. And so my yt would simply be equal to 4 times 3 squared, because I'm putting 3 right here, minus 24 times the 3 plus 31. I'm going to use a calculator to work this out. So it is 4 times 3 squared minus 24 times 3 plus 31 with a negative 5 for my yt value. So my turning point of those coordinates. But the expression becomes in the standard form. You can write it out. The 4x squared minus 24x plus 31 becomes in the standard form, in the vertex form, a, which is 4, into x minus xt, which is 3. Don't forget the square. And then the plus yt is negative 5. So this plus yt is negative 5 minus 5. And that is it. Next part now says, on the axis below, sketch this graph. Sketch a graph of that. It's a function indicating the coordinates at a maximum or minimum point. So I'm going to cross out the word maximum because we actually do have a minimum point. And the graph is going to have a smile shape with a minimum point. How do I know that? Because the A value is positive. When the A is positive, the graph will have a smile shape and will have a minimum point. All right, and the minimum point will have these coordinates. So we can actually put it here. All right, so the minimum point is xt, yt that I've calculated, which then will become 3, negative 5. All right, additionally, this is your y-axis intercept, this 31 would be a y-axis intercept. But the question is also asking us for that. The y-axis intercept is always 0 and the c value. All right, and the c value is 31. So that is 0, 31. 0, 31. And this is just a sketch, no scale there. What do we know? Let's sketch it. Let's reason it out. So the minimum point is this, and that point will be the negative quadrant down here in this quadrant, where the x value is positive and the y value is negative, right? Because the x value is positive, meaning go this way to the right, and the y value is negative, means you go somewhere down here. So when it turns somewhere down here, all right, so let's mark that. We know that it's going to turn somewhere down here, all right? So it's going to turn in this quadrant, and then this point, 0, 31 is on the positive side of the y-axis. So the graph must cross the y-axis somewhere up here, So basically, we need a smile graph that will cross somewhere up here and turn down here. So that graph could maybe go like that. I'm drawing it in purple. It's not to scale. All right, so I'm going to leave that as it. Let's see if we can draw it a little bit better. All right, let me take out these markings now. So we have that, right? So it turns down here and crosses up here. Let's need to label those points now. So this minimum point is 3, negative 5, and this point is 0, 31, 0C. And that's the sketch of the graph. So we can label it up, sketch of y equals 4x squared minus 24x plus 31. And if that asks for the axis of symmetry, it would basically be the vertical line passing through the vertex. This point is called a vertex. And this axis of symmetry or line of symmetry will be vertical like that. That would be the axis of symmetry. They didn't ask for it this time, but we are learning still axis of symmetry. Axis of symmetry. Let's put this one in for symmetry. And the equation of it is x equals whatever the x value is at the turning point. This value, x equals 3. Because a vertical line crossing the x-axis at 3 right here. All right, so basically that is it. Just zoom this up and shift this over. They didn't really ask for this, but so it's good because they could have asked for it. Right? This red line is the axis of symmetry right here. All right, I think that finishes this question. Nope. Oh, the axis for it. Hey, state the equation of axis of symmetry. Yes. So I didn't realize. So the axis of symmetry is always x equals whatever the x value is at the turning point. All right. In this case, it is x equals 3. The x value at the turning point is 3. And so that is the answer. And we have shown it on the graph there as well, right here. Then they asked us to show it, but I did. All right. I remember that this is now a minimum point. So let me say that it's a maximum. It's a minimum crossed out the max. So this is actually a minimum point. Minimum point. Minimum turning point. All right. Question done. All right, guys. So that finishes number 8. And we will continue with number 9 in the next video. Okay, see you then. Number 9 next.